So, good day everyone. I am here to discuss what is binary insertion sort and how does it work. So, let's proceed. So, binary insertion sort, it is a special type of insertion sort which uses binary search algorithm to find out the correct position of the inserted element in the array. An insertion sort is a sorting technique that works by finding the correct position of the element in the array and then inserting it into its correct position. So, binary insertion sort, it is a classic sorting algorithm that has taught in schools everywhere, and it is similar to the insertion sort, but instead of using linear search to find the location where an element should be inserted, we use binary search. So, what does it mean? Binary insertion sort is the improvement of the insertion sort. So I have here an example. Oh no, wait. Before we're to uh, going to have an example, I'm going to explain why. What is this? So binary insertion sort is a flexible algorithm and a stable filtering algorithm. So from the word flexible, it means it works faster than the other, and then stable from the word stable. So now we are going to have the example. We have this example, the unsorted list. So we have here the unsorted list 3714625. So let me get here to my notepad so that I can show you how binary insertion sort works. So I have this. I'm going to copy the unsorted list 3714625. So in binary insertion sort, we need to make these elements or this number of variables to get to find where its correct position is. So by looking at 3, we need to compare it to its left side, but number 3 doesn't have its left side. So wait. So going to number 3. Number so 3 remains stable, remains constant because it has no left side that needed to be compared with. So we we need to proceed to number 7. So 7 is greater than 3. So it also remains constant. Then let's proceed to number 1. So by this, 1 is lesser than 7 and also 3. So we need to make it go, we need to put number 1 into its correct position, where we need to reorganize this list. So the result will be 1, 3, 7, 4, 6, 2, 5. Then next, so it now we already have put number 1 into its correct position, where 1 is lesser than 3 and 7. So we need to proceed to number 4. So 4 is lesser than 7, but it is greater than 3. So what are we going to do? We need to put number 4 into the correct position. So 1, 3, 4, 7, 6, 2, 5. So next, now we put number 4 into its correct position. Then let's proceed to number 6. So 6 is lesser than 7, but it's greater than 4. So we need to put number 6 into besides into the left and to the right side of number 4. So it becomes this 1, 3, 4, 6, 7, 2, 5. And we proceed to number 2 because we already have put number 6 into its correct position. So number 2 is lesser than 7, lesser than 6, 4, and 3. So where are we going to put number 2? So we are going to put number 2 beside number 1. So the result will be this 1, 2, 3, 4, 6, 7, 5. Now 5 is the remaining number that needs to be corrected. So 5 is lesser than 7 and also 6, but it's greater than number 4, so we need to insert number 5 in the right side of number 4. So 1, 2, 3, 4, 5, 6, 7. So now this is the result. This is not the sorted list. So that's how um, binary insertion sort do. It he will it will put the put the elements to its correct position if given the if it is given the unsorted list that binary search will do. So we're going to go back now. Becomes this sorted list 5, 6, 7, 5. So now we're going to continue the applications of binary insertion sort. Binary insertion sort works best when the array has a lower number of items. Oh, wait, I didn't explain why it is stable. So, out of the given options, binary insertion sort is the only algorithm which is stable. It is because the elements with identical values appear in the same order in the output array as they were in the input array. So, let's continue. Binary insertion sort works best when the array has a lower number of items. So, as what I've said earlier, it means it works faster. So, the lesser it has, the faster it gets. So, when doing quick sort or merge sort, when the sub-array size becomes smaller, say it's lesser or equal to 25 elements, it is best to use a binary insertion sort. So it has this. If it is lesser or equal to 25 elements, then it is best to use the binary insertion sort. So this algorithm works when the cost of comparisons between keys is high enough. So for example, if you want to filter multiple strings, the comparison performance of two strings will be higher. So how does binary insertion sort work? So in binary insertion sort mode, we divide the same members into two sub-arrays, filtered and unfiltered. So the first element of the same members in the organized sub-array and all other elements are unplanned. And then we iterate from the second element to the last. In the repetition of the ith, we make the current object our key. So what is this word key? So this key is a feature that we should add to our existing list below. So in order to do this, we first use a binary search in the sorted subarray below to find the location of an element larger than our key. Let's call this position pos. We then right shift all the elements from pos to 1 and create an array pos equals to key. Then so on and so forth. So approach to element binary insertion sort. Iterate the array from the second element to the last element. Store the current element AI in the variable key. Then find the position of the element just greater than AI in the subarray from AO to AI minus 1 using binary search. Say this element is at index pos. And so before going to end, I have here an example of a code. So, code so that so here it is. So this is a sample of a code where it is a binary search based function. It is to find the position and where items should be inserted, or whether in a low or high. So going to explain how it works. So the code in the function is used to find an item in a list. The code starts by checking if the item is less than or equal to low, which would be 0. So if it is not, then it returns to mid plus 1 and continues on with its search from there until it finds what was being searched for. So binary search function takes two parameters, the int a and then int item, and returns an value integer value indicating where in the list this particular value can be found, whether in a low or high. So it starts by checking if high is lesser than or equal to low and returning false because they are they are both greater than 0. Then it checks whether the current number is less than or equal to mid minus 1 minus 1 and returns true because that's where this number will end up when you continue searching through all values between low and high. So after after finding out where this number should be or where this number should go in relation to other numbers in the list, binary search goes back one more time using mid as starting its point instead of low, so that when you get back here again later on during your search process, you know how far down. So the code will search the value of an item in a list of integers. So if the value is found, it will return the index of that item. If not, then it will return the index of mid plus 1. So now we are proceeding to this function. So function to sort an array A of size n. So as you can see, this part find location of elements of the location. So this process will be now the binary search, or now this will be the correcting the position. So the code this code is a function that takes an array of integers and inserts elements into the array in order. So the function starts by iterating through all the numbers from 1 to n, which is the side of the input array. It then finds where selected should be inserted using binary search. So the code first moves all elements after location to create space for selected's insertion. Then it sets selected as a new value at its current position in the list and sets its old value as a new element before it so that there are no gaps. So the code is used to perform an insertion sort on a list of integers. So the code starts by initializing the variables I, j. So this, like, this is where this is it starts. Selected line 1. Then the line 2 begins the for loop. Then line 3 sets up the variable location, where which where it will be used to find where to insert into the list. Then line 4 sets up a binary search using a selected as key and 0 as value. So the variable j is set to point at where we are searching for. So, so in this line, while j is greater or equal to location, so all elements after location are moved down one position so that there is room for what we want to insert into our list. So this it summarizes that this is where the um this is where the locating the correct position. So last but not the least, the last function of the code is this. So the code the code is a simple insertion sort. See, there is an example of this. It's given 37, 23, 0, 17, 12, 72, then so on. So the function inserts the value and position into the array and then compares it to the next value in order, which is at position I plus 1. So if they are equal, then that value is inserted into position I plus 2 and so on until all values have been stored. So int main, so in this in oh no int main. So in this function, the int 8 7 size of it brings out the sorted list of elements from start to finish with no spaces between them. So the code attempts to sort an array of integers. And then the code declares a local variable n, which is the size of a. And then it creates an insertion sort. It takes two parameters a and n. The a and n function will be called with the values 37. So this function will be called with the values 37, 23, and so on. So each time it is invoked. So the value 54. So you can see this value. So the value for 54 will not be passed into this function because it would go past the end of the array. So the first line of code creates an integer a that has 4 elements. So these are 37, 23, 0, and 17 respectively. So the second line declares a local variable which is equal to size of a dash or divide size of a. Then so on and so forth. This is how the binary insertion sort do. This is the example code. So summarize. So in summary, in this function, um, the code the code process and the code in the function is used uh, to insert the element, whether it is a low or high. Then just like what I have that's just like what I have explained in the other notepad, like the 3 7, which is 3 is which is 7 is lesser than 3, 7 is greater than 3, so it remains stable because 7 is higher. So it's just like this. Then this function where where it needs to locate where the selected item should be inserted, and then it moves all elements after location to create space. Lastly, this will be the um, reference to process this code, this function. So that would be all for my discussion of how binary insertion sort do. So if you have any questions, um, just look at my document where I research what what is binary insertion sort and how does it work, because I put all the necessary information to provide the information you need. So that would be all. Thank you. God bless.